All right, so here we have these two triangles, right? These are special right triangles. We call this a 45, 45, 90. And we call this one a 30, 60, 90. And the key here is the relationship between the three sides of these two special triangles, okay? So in this case, a 45, 45, 90 right triangle, okay, this is called an isosceles triangle because these two sides are the same, right? It turns out that the hypotenuse is going to be whatever this length is times radical 2. Okay, now this is just a property that is well known, right? It's given, something that we just have to know. Okay, similarly, in the 30, 60, 90 right triangle, okay, what is the relationship between the sides? Well, the shortest side is always, we'll just call that x. Okay, so the shortest side we'll call x. And then the longest side is the hypotenuse, is always going to be twice the length of the shortest side. Okay, and then the side opposite the 60-degree angle is always going to be x, the shortest side, right? X times radical 3. And once again, this relationship is just given, right? You just have to know this. I'm not going to go ahead and prove this, right? Okay, but how can we sort of deal with this? Okay, so this is the main idea, right? If this is a 45, 45, 90 triangle, right? Let's say this length here is 1, right? If this length is 1, then what are these two sides going to be? Right? Notice it's not going to be radical 2, right? Okay, the idea is that this is equal to x radical 2. So we have to actually solve this for x. So if x radical 2 is equal to 1, we'll divide both sides, right? So x is 1 over radical 2, which, when properly rationalized, equals rad 2 over 2. So that means in this particular right triangle, in this 45, 45, 90 right triangle, if the hypotenuse is equal to 1, then the two sides are rad 2 over 2 and rad 2 over 2 here. Now these numbers should look familiar. Okay, we'll go into that in a little bit. What about this 30, 60, 90 right triangle? Same idea, right? What we want to do is, let's say we have this guy. I'm just going to draw it out again. Right? Let's say the hypotenuse is equal to 1 here. Then what are these two sides going to be? Well, we know that the relationship is that 1 is the hypotenuse is equal to 2x, right? What we want to do is we want to solve for x. So if 2x is equal to 1, then x is equal to 1/2, which makes that this side here, right? This side is equal to 1/2. And it turns out that this side is the shortest side times radical 3. So we get radical 3 times 1/2, which is radical 3 over 2. Now, I do want to point out one thing here, right? It really doesn't matter how this triangle is oriented, right? We can put the 30-degree side here. We can put the 60-degree side here. Either way, this is going to be 1. This is going to be 1/2. This is going to be rad 3 over 2. Okay? So why is this important? Well, remember that this all goes back to unit circle, if you remember, right? If you look back on the unit circle, we'll just deal with quadrant 1 here. Okay? If it's not a really nice half circle, is it? So let's try to draw a little bit nicer circle if we can, right? What about this, right? Let's do this. We call this 30 degrees, okay? And this is 1, right? If this is 30 degrees and this is 1, then what can we say about these two sides, this x and y value? Okay, well, if this is 1, this is 30, then this has to be 1/2, right? So we can see that the x value is rad 3 over 2, the y value is 1/2, right? That's where these numbers come from. Okay, that's why the unit circle is so important, right? That's why we call the 30 degrees, the 45 degrees, and the 60 degrees here. Those are the 3 special values. And we know that in each quadrant, there's just multiples of these, right? That's why the unit circle only has, we'll call it these 12 special values. Okay, so some of you may be asking this, right? Well, okay, what if we have something like this, and this is like, I don't know, like 40 degrees here, then we know this has to be 50, right? Is there some like special relationship like this? The answer is no. Right? Now, it doesn't mean that we can't find the sine of 40 or this, cosine of 50 or something like that, right? But it just turns out that the only two special values or the two special right triangles are the 45, 45, 90 and the 30, 60, 90. Okay. I do want to make one extra point here, right? One extra point. Sort of running out of space here, right? But let's say we have a 30-degree angle here, a 60-degree angle here, right? Remember, the hypotenuse doesn't always have to be 1. Okay? So, for example, let's say this is, I don't know, let's say this is 8. The hypotenuse is 8. Then can we get these other two sides? The answer is yes. Right? We know that the side opposite the 30-degree angle is going to be half the hypotenuse, so this is 4. And then this side here, right, the side opposite the 60-degree angle is going to be 4 radical 3. Okay, but what do you notice? What can you tell me about the sine of 30 degrees? Remember, sine is opposite over hypotenuse. In this case, opposite over hypotenuse is 4 over 8, which is 1/2. Right? Think about what that means. The sine of 30 degrees is always 1/2. It doesn't matter the size of the triangle or what length the hypotenuse is. The sine of 30 degrees is always equal to 1/2. Very similarly, if I ask you for the cosine of 30 degrees, right, it'll be the adjacent side divided by the hypotenuse of 4 radical 3 over 8, which is just rad 3 over 2, right? And what does that mean? It means that cosine of 30 is always radical 3 over 2.